and welcome to another video of Smart E Academia International. Our today's topic is going to be on arithmetic sequence and series and geometric sequence and series applications. Let's see initially the applications of arithmetic sequence, and the very first application is simple interest. Suppose you invest $100 and you get annual return of 10% per annum on the principal value. Now, getting the principal value return on the principal value means you do not have to compound every year. It means this is a simple interest question. So what happens that you initially invest $100, then you get 10% of return every year on the principal amount. So what is 10% of 100? We can simply calculate by converting percentage to fraction. So multiplying with the the principal amount, we get $10. So $10 is the return that the person or we will get every year. So in the next year we get $110. This is just simply found by just adding 10 in the previous value, and then the very next year we get $120, $130, and so on and so forth. And we can just find this by just adding $10 on the previous term. And as we know, this is a characteristic of an arithmetic sequence and with the common difference of 10. So this is surely an arithmetic sequence, which means that simple interest is an application of arithmetic sequence. Now, in order to derive the simple interest formula, I would like to write my numbers differently as I did for proving the arithmetic series journal formula. So 100 will be just written as 100. There will be no change in that. However, 110, I want to write it as 100 plus 10, 100 times 10 over 100 times 1. Now, there's a reason why I have written this, and you will see it. Similarly, basically what happens is 100 cancels out, and 100 plus 10 gives you 110. Similarly, 120 can be written as 100 plus 100 times 10 over 100 times 2. Similarly, 130 can be written as 100 plus 100 times 10 over 100 times 3, and so on and so forth. Now, if you notice in this case that your 100 remains the same, even if you want to write this, you can still write it as this also you can write it as 100 times 10 over 100 times 0, because this whole thing just vanishes. So in all these situations, you can see 100 remains the same. 100 remains the same in all the values. Then your again, this 100 also remains the same. We're using the same color. There's a reason for that. Then this 10 over 100 also remains the same for all these terms. The only difference we have is the 0, 1, 2, 3. Now, if I wish to write this, first of all, let's try to understand what is this 100, these 100 terms. What is this 100 in terms in context of my question? So 100, if you notice, is basically the present value. What do you mean by the present value? It means that how much you have invested in year 0. Like presently, your investment has a certain value. We all know when we will study compound interest, as we have invested something in a particular bank or in a particular venture, the value of that investment does not remain the same. It has to be discounted because of inflation, because of interest rate, and basically it's a term what we call the time value of money. So we'll study that later on. So that's why the terminology present value means the value of investment or money at year 0 or today. Then if you see this 10 over 100 is basically nothing but a fraction form of the interest rate or the return rate. I can represent this with an R, okay, and I can say it's in decimal form, for instance. So in this case, it's basically 0.1. And then if you see this thing, this 0, 1, 2, 3, this I can represent as my time. So t equals to 1 means this is my year 1. So for that, correspondingly, I have t equals to 1. Then I will have year 2. Correspondingly, I have t equals to 2. Then I have this year 3. Correspondingly, I have t equals to 3. So if I want to write my general term in the same way, that what is going to be, I can call this FV, which is the future value. So future value means my value of my investment in the future. Remember, in simple interest, we do not take in consideration the discounting or the time value of money. This is just simply calculating the returns. So my future value of my investments, for example, if I want to calculate in year 1, year 2, or year 3, would be present value, which corresponds to the first term, plus another times I need to write present value, which is this terms, times R, which is the interest rate, times T, which is the time where I want to calculate. This is pretty straightforward, as you can see. Now we can take present value common, so this will become PV, and what is left is 1 plus R times T. So this is the formula of simple interest, where PV is what I call the present value, FV is what I call the future value, where I'm willing to calculate it. R is your simple interest per annum. PA stands for per annum. And here you will always write that in decimal form. So for instance, if your interest rate, let's say R is 3%, you will write this as, that 3 over 100, which is 0.03. You will not write it as 3. So don't make this mistake. And T is the time in years. and after how many years you want to calculate. Now, sometimes the question can arise that your interest or return is per month 10%. Okay, so if you need to understand that the interest rate and time must have the same units. So if you are calculating your R, if I say is 10% per month, and you want to find what will be your return after 1 year, T you will not take as 1 year, you will take as 12 months. So remember what I'm trying to say here, that whatever is the value of or the units for R per month, per quarter, per year, per semi-annual, this time should have the same units as well. So this is something that is highly important in solving this question. Now we can also calculate the interest, that what is the interest that someone pays on, or in simple way, what is the interest someone gets, beg your pardon, not someone pays, because that's something that you pay in the loans, but what will be your return or what will be the interest that you will get? It can be simply found by subtracting future value from the present value. For instance, after year 3, your return or your total investment turns out to be 130, whereas your present value, which means the one you invested, was $100. So you have gained an interest of $30 after 3 years. So this is a pretty straightforward application of arithmetic sequence. As you can see, you can use simple arithmetic formula as well, the one we studied previously, which was un equals to u1 plus n minus 1 into d. But this is again another formula, which is a financial formula, which is derived from. Now let's look into some of the questions related to this particular topic. The question says that James invested £200 for 1 year in a bank account. The account pays simple interest at a rate of 3% per year. Work out the total amount of money in the account at the end of the year. So this is pretty straightforward. I'm going to use the same formula that I wrote for my simple interest. Now, in this case, what's given to me is the present value, which is £200. The interest rate is given as 3% per annum or per year, and do not make this mistake, this has to be 0.03, not 3, because I said R must be written in decimal form, not in percentage form, whereas the time here is simply 1 year. Now, please understand, this is per annum, this is per year, which means the units are same. That's why I will write T equals to 1 in this case. So what will be the future value after 1 year? Simply 200, 1 plus 0.03 times 1. And if you substitute this in the calculator, you get £206, which means that James will have 206 at the end of the year. The next question says that Jonah invests £400 in a bank account that pays 3.5% simple interest per year. At the end of each year, Jonah spends 3/5 of the interest. Now this is highly important because he's spending 3/5 of the interest that he gains, not the total value of the money, and gives the rest to his brother. How much money does Jonah give to his brother each year? Now let's try to write what values are given in this question. First of all, the present value or the value of the investment is £400. The rate of return is simply 3.5% per annum, which my decimal would be 0.035. Whereas the time here in this case is simply 1 year, because we are trying to find how much money Jonah gives to his brother each year. Now, it is important to note that my rate of return is per annum, whereas my time is in years, which means I have both of them as same units, which is easy for me to solve now. To calculate the future value, because I would need that how much is the future value of Jonah investment after 1 year, I can simply use my simple interest formula, which is present value times 1 plus R times T. So my present value is 400 and my R is 0.035 times 1. Substituting this in the calculator, I get £414. This means that the value of £400 in 1 year for Jonah is now 414 after 3.5% simple interest rate. Now, in order to calculate how much interest Jonah receives, this is important because I need to calculate how much of the interest amount Jonah spends. So the interest is going to be simply subtracting present value from the future value, which in this case is £414 minus £400, which turns out to be £14. Now, we know that Jonah spends 3/5 of interest, whereas how much does he give to his brother is simply 1 minus 3/5 of the interest, which means that, which is 2/5 of the interest that he has received. So 3/5 means out of 5 parts, 3 parts Jonah spends, and the rest 2 parts he gives to his brother. So this is now straightforward. How much Jonah gives to his brother is simply 2/5 times the interest, which is 14, which is pretty straightforward. If you substitute in the calculator, you get 5.60. Now this is very important. Whenever you get a decimal and you are working as a financial questions, you must and always round to 2 decimal places, because we know that the cents have a 2 decimal place value, and that's how it is going to be. So it is in this question, Jonah gives his brother 5.60 or £5.60 each year. The next question says, Nicole invested some money for 3 years into an account that pays 2% per year simple interest. She earned 7.20 pounds interest in total. How much money did Nicole originally invest? Now, it's the same question, but a different variable needs to be found. In this case, we don't know what is going to be my present value in this case. And in order to find that present value, I need to see what other variables or what other numbers are given to me. So it says the time is 3 years, pays a 2% per year simple interest. So my R is going to be 2% per annum. So which is obviously going to be 0.02. She earned 7.20 interest. Now this is the interest that she earned. So the interest that she earned is basically pound 7.20. Correct? Now what I need to find is the present value. Now this is a very important notion here, that our formula does not have any interest in the formula of the simple interest, right? That how to calculate the interest from that. We have two different formulas, and somehow we have to combine these two formulas. So the formula for the simple interest is future value equals to present value times 1 plus RT. Whereas the formula for interest is future value minus present value. Now we have already given that our interest is 7.20. We also know the future value. We don't know the future value, beg your pardon, minus present value. Now the future value can be simply found, or I can write my future value as 7.20 plus P simply by taking this thing to the other side. Now what this did for me is I can simply substitute this value here, and my equation will be in only one variable form, which is in the form of the present value. So if I substitute this, I will get 7.20 plus present value equals to present value times 1 plus my R is 0.02 and my T is 3. Now if you notice, now my equation has only one variable, and as I told you before, to solve a one variable problem I need one equation. To solve a two variable problem I need two equations. Now here indirectly, because I already had two different variables, I did not know the future value. So if you see here, I did not know the future value and I did not know the present value, so I needed two equations. So I needed two formulas to solve them. So what I did was, from one of the formula, I eliminated one of the variable by making one of the variable a subject, and then substituting this value back into this equation. Now I just have to solve this algebraically, which is pretty straightforward. First of all, I can just simply write 7.20 plus present value equals to, let's try to solve this particular thing. And if you do it, you would see that it turns out to be 1.06 present value. Simply 1 plus 0.02 times 3 is simply 1.06, and multiplied it with present value, it's 1.06 times present value. Now I can make my present value or my variable together on one side. I can take this side. So what happens here is this thing becomes 1.06 present value minus present value, and if I just use it, 1.06 minus 1, this gives me 0.06 present value 7.20. In order to find the present value, I can just simply take this thing down, and my present value will turn out to be 7.20 over 0.06, which gives me 120 pounds, which means that the initial value or the present value was 120 pounds. Now, if I wish to calculate the future value, I can by simply plugging this in here. So this would be simply future value would be equals to 120 plus 7.20, which is basically 127.20 pounds. The next question says that Evie is saving up to buy a guitar that cost 109 pounds. So the value or the cost of guitar is 109 pounds. She opens an account at Cobra Bank that costs or that pays 3% per annum simple interest. So my simple interest in this case is 3% per annum, which is basically 0.03. She puts 800 pounds into the account, which means the present value in this case is 800 pounds. Evie does not make any deposits or withdrawals, which means she does not withdraw or deposit any more account in the bank. After how many whole years will Evie have earned enough interest to buy the guitar? Now this is a very important notion. She does not want to spend her original investment to buy the guitar. Rather, she wants to convert her investment to a value where the interest would be enough to buy the guitar for her. Now in this case, with simple thing, your interest is given, that she wants to achieve an interest of $109. Now in this case, what you're looking to find is the time that will give you this particular interest. Now if you notice, you have two unknowns here. You don't have the future value as well, because in our formula for simple interest, the formula says future value equals to present value 1 plus R times T. Now we know that we do not have the future value and we do not have T, and I said whenever you have two variables, there has to be another equation that you need to solve, and we know the other equation is simply interest equals to future value minus present value. Now in this case, interest is given and present value is given, so I can simply find the future value from here. So interest, we know, needs to be calculated as 109 to buy the guitar, whereas the future value is something that needs to be found, and my present value is simply 800. Just putting this thing here, your 109 plus 800, the future value will turn out to be pounds 909. Now once we have found the future value, I can simply substitute all of my other variables or numbers into my equation. So future value is 909 equals to the present value is 800. 1 plus r is 0.03 times t. Now we know that this 800 SB is multiplying with this, so I can just simply take this thing down and it will be divided, and it will become 909 divided by 800 equals to 1.03t. 909 over 800 in the calculator will give you 1.13625, which is equals to, again, 0.03t. Now I can simply take my 1 to the side, and if I subtract it, it goes and subtracts, give me 0.13625 equals to 0.03t. Now I can simply take the 0.03 down to find the value of t, which is 0.13625 over 0.03. And the answer to this is 4.54 years, and so on and so forth. But the question says you have to round the years to a whole number, and the nearest whole number in this case is 5 years. Now you need to understand this. Let's say your answer came out to be 4.2 years. Now you would say, sir, that 2 is not greater than 5, so rounding this off will give you 4 years. But this is not correct in terms of the questions, because we know that in 4 years, she will not have enough amount to buy the guitar. Even if she gets 4.1 years to raise that money, you will still write 5 years, because only after 5 years, she will have enough money to buy the guitar. So this is something that needs to be taken into consideration, and that is unconventional to what we do in simple approximations. The next question is simply a comparison of two investments, and based on your calculations, the examiner wants you to come to a conclusion that which investment is better. So it says that Solomon wants to invest £600 for 3 years. Now it has two banks with different offers. The Corbett Bank gives an offer of 2% per annum simple interest, straightforward, whereas the Banks R Us gives an offer of 2.5% per annum simple interest for the first year and 1% per annum simple interest for the following years, which means for the next 2 years. In this case, what you need to do is do different calculations for different years. Let's say, if I say Corbett Bank, this is pretty straightforward. We have the present value, which is £600. Time is 3 years. Rate of return is 2% per annum. So everything is right in terms of my units. The time is also in years. The rate of return is also in years. So my R will be 0.02. So in order to calculate the future value, I can use the simple interest formula. My future value would be 600 times 1 plus R is 0.02 times 3, because he wants to invest for 3 years. And my future value turns out to be £636. Now for Bank R Us, we have to do two different calculations. First is for the first year. For the first year, and I'm doing this for Banks R Us, your present value obviously is going to be 600. The time now is going to be 1 year, because 2.5% only for 1 year, and R is 2.5% per annum. So in this case, R will turn out to be 0.025. And my future value would be, after 1 year, remember, will be simple 600, 1 plus 0.025 times 1. So just simply putting this in the calculator, I get £615. So this is my value after 1 year. Now remember this was year 2, this was year 0. So you had £600. After year 1, you have £615. Now I need to calculate for 2 and 3. Now this is gone now, which means now I start my calculations from here, because here I get my my interest or simple rate of return as 1% for the next 2 years. Now what I'll do, present value would be 615, because now I'm in this year. So this will just start as 0 year. This is my first year and this is my second year, because this has already been calculated. Now I'm at this instant. The second thing, the time would be now 2 years rather than 3 years, because I've already calculated for 1 year. And from that, future value is my present value right now, because I'm going to find how my $615 will increase after 2 years with a 1% simple interest per annum. And similarly, my rate of return will be 1% per annum, which is 0.01. So all I have to do is calculate my future value. My future value would be 615, 1 plus 0.01 times 2 for the 2 years. So 615 times 1 plus 0.01 times 2. The answer is £627.30. So it is clear that the offer of Corbett Bank, the offer for the Corbett Bank, is much lucrative, because it is giving you a much higher return or a much higher future value as compared to Banks R Us, although it was giving you a good initial rate of return for the first year. In the next application, we'll be seeing of the geometric series, that is the compound interest. Suppose you invest $100, which increases annually at 10% compound annually. Now it means that every year, whatever return you get, it will compound 10% every year. So which means it will exponentially increase as compared to the linear increase that we had for the arithmetic series. Now, to understand how this is a geometric series, let's try to understand or see how the money would increase after each year. So let's say at year 0, we know that we have just $100. whereas at year 1 we will have $100 plus 10% of the $100, and we know 10% of 100 is basically 10, so we'll get $110. Now things starts to change after year 2. So what happens after year 2 is that it will be 110 now, not 10% of the principal value, but from the previous value. This will be plus 10% of 110. So 110, what's 10% of 110 is basically 11. So the answer is going to be 121. Similarly, if I go for year 3, now I need to calculate 10%, adding 10% of 121, or the previous term. And 10% of 121 is, if you calculate this and put this in the calculator, you'll get 133.10. Let's try to write this in a series form and see whether it is a geometric series. So we have year 0, we have 100. Year 1, we have 110. Year 2, we have 121. Year 3, we have 133.10, and so on and so forth. So if I want to divide, let's say I know this is U1, U2, U3, U4. So I want to do U2 over U1, which is basically 110 over 100, I get 1.1. If I want to do U3 over U2, which is 121 over 110, I still get 1.1, which means I have a common ratio. So every term is found by simply multiplying 1.1, which means it is indeed a geometric series with a common ratio of 1.1. Now, the derivation of the compound interest formula is a bit complex one, and again beyond the scope of your course. So I will just write the formula and try to explain each component of the formula. So the future value for the compound interest is basically present value times 1 plus r over k bracket power kt. Now you need to understand each terminology here. As for the simple interest, similarly, we have FV as future value, which means what would be the value after a certain year. Present value is your initial investment that you do. R is obviously the interest rate. And this is something that, again, you will write in decimals, not in fractions, not in the percentage form. And T is in years. Now, there's an extra variable here, which is K. K is basically number of periods per year. What does that mean? I'll explain you. Now, sometimes some banks or some investment firms compound the interest at different intervals. Some do it annually, some do it quarterly, some do it monthly, and so on and so forth. Now, how will we incorporate that? Let's say if a bank says, or an investment firm says, that your investment will be compounded or percent compound annually. In this case, we know I'm talking about my K is what? Number of periods per year. We know that there is 1 year in a year because it's talking about annually. So K will be 1. Now let's say it says that your investment would be compounded quarterly. Now here K value changes. The K value in this case would be 4. Why? Because there are 4 quarters in 1 year. Similarly, if my interest rate is compounded monthly, let's say, my K value would become 12 because there are 12 months in a year. And similarly, if it's compounded daily, my K value is 365 because there are 365 days in a year. So depending upon the compound, yearly, annually, monthly, the K value would change, and that's how my formula would change. Another application for geometric series is the exponential growth or exponential decay, or simply depreciation of assets as well. For the general formula that we use is P equals to P naught 1 plus R power T. Now please notice the similarity in the compound interest formula. It was future value equals to present value 1 plus R over K times T, KT. So what's happening here is this K is nowhere to be seen in this particular formula, because in this case K is 1. When we talk about appreciation or depreciation, growth or decay, we usually talk about annual, and we said that for annual K is equals to 1. So this formula is basically for growth. So this is your growth formula. When it comes to the decay formula, the only difference we have is 1 minus R power T. So it's simply, if it's a plus, there will be an exponential growth. If it's a minus, it will be an exponential decay. So which means that this is another application for a geometric series, which means in this case, R is going to be the percentage increase or decrease per annum or annually. And T is obviously the time. And we know that this has to be same in years. It's per annum, so this will be in years as well. So this can be population growth, this can be bacteria growth or decay, this can be salary increase or decrease. All that things can basically jumble up in this particular formula, and we can have maybe let's say V equals to V naught 1 minus R power T. We can tell you the value. A equals to A naught 1 minus R power T. A could be the, let's say, the amplitude, whatever variable, but the decorum or the structure of the formula will be the same. Now let's look into the questions. The first question says, UK retirees are migrating to holiday homes in Spain. Every year, 2.3% of UK residents move to Spain. In 2021, there are 2,700 UK retirees. How many retirees would be in 2027? So basically what we are trying to find here, this is a timeline. So we are in 2021, and in 2021 we had 2,700 UK retirees. We want to see how many retirees would be there after 2027, or at the end of 2027, when the population is increasing by 2.3% per annum. So this particular elaboration gives you a good idea how to solve the question. And we know that it's an increase question, so the formula can be used as P equals to P naught 1 plus R power T, as we discussed previously. Now, in this case, we know that the initial population is 2,700 UK retirees. The growth rate in this case is 2.3% per annum, which is basically 2.3 over 100, which is equals to 0.023. Whereas the time in this case is 6 years, because we are trying to find how much our population would increase after 6 years. We can just simply plug in these values in the formula. P equals to P naught is 2,700, 1 plus 0.023 power 6. Just substituting, we'll get 3094.69. Again, we cannot round this off to 3095 because 0.69 of a person is no person. So we can say that the population is 3094 approximately, which means that at the end of 2027, Spain will have 3,094 retirees at an annual increase of 2.3%. The next question says the value of a car depreciates. Now this means that it's depreciating at a rate X%. In 2020, the value is £21,000. In 2028, the value of the car is approximately £11,255, which has decreased, obviously. Find the value of X, which means the depreciation rate. Again, you can say V0 is the initial value of the car, which is £21,000. The final value of the car is basically £11,255. We need to find the depreciation rate, which is X%, that how much is the depreciation rate. Whereas the time is given in this case is basically 8 years, because it is from, if I draw the timeline, we know this is 2020, this is 2028. We know that the value at 2020 was £21,000. The value at 2028 was 11,255. We want to find the depreciation rate. We can use the formula V equals to V0, 1 minus R power T. It's important to note that minus suggests that the value is decreasing. So whenever the value is decreasing, you will use the decay or depreciation formula. Now notice I've just used V equals to V0. I can change P equals to P naught or A equals to A naught depending upon whatever variable I wish to use. But the structure of the formula must remain the same. Now let's plug in the values. V is 11255, V0 is 21,000, R is X, which I need to find, and T is 8. Now all I need to do is solve for X. So I will bring this thing down. It will become 11255 over 21,000 equals to 1 minus X power 8. This gives me 0.536, rounded to 3 significant figures, 1 minus X power 8. Bringing this 8 to the side, my power 8 will become 8 root of 0.536, gives me this answer, and I get X, this equals to 0.9013 equals to 1 minus X. Now to solve for X, I can bring X to this side and bring this to this side. My X becomes 1 plus 0.9013, and 1 minus 0.9013, and my X turns out to be 0.09873. And I want to convert this into percentage. I can simply multiply by 100 and I get X equals to 9.87%, correct to 3 significant figures, which means that the car depreciates approximately 9.87% per annum. The next question is about compound interest. Tamsin invests $750,000 in a saving account which pays 3.8% per annum interest rate compound quarterly. How much money will be in the account when she retires in 10 years' time? Let's write the compound interest formula first. It was future value equals to present value, 1 plus R over K power KT. Now let's see what values are given for me. Now this is straightforward, that we need to find the future value after 10 years. So my time is again 10 years. Now what is the value of my K? That depends on my R. R is 3.8% per annum, compound quarterly. Now we know that there are 4 quarters in a year, so we'll have K equals to 4. Now my R can be calculated as 0.038 in decimals, and my present value, as it says here, is 750,000. Now all I need to do is plug in these values and find the future value. So my future value would be 750,000, 1 plus 0.0384, 8 divided by 4 because K is 4, and 4 times 10 because T is 10 years and 4 is the value of K. So all I have to do is just plug this whole thing in my calculator and get the answer at 4 times 10 will be 40. and I will get 1094748.086 blah 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 blah. In order to calculate this in a proper money format, this will be 1,094,748.09. So this would be the value of the investments after 10 years, which means 750,000 now will be appreciated to this value after 10 years. So this is the questions about compound interest and compound interest, simple interest, growth, decay, which are the applications of arithmetic and geometric series. If you have any other questions, please put them in the comments so we can address them.